Okay, hello, this is our first video back from spring break. So this is lesson 2 video notes for creating exponential functions, unit 10. So we got to get rid of our jelly beans from Easter, and let's start out with a little warm-up for this lesson. So can we find the pattern in these numbers? 2, 5, 8, 11, 14. Finding the pattern is going to be important in this unit. So what do we have to do? To go from 2 to 5, add 3. From 5 to 8, add 3. 8 to 11, add 3. 11 to 14, add 3. So the next number would be 17. That's a pattern we found before. This type of pattern and on 3 are the patterns we're going to deal with in this unit. So how do I get from 2 to 6? Well, I could add 4, but if I add 4 to 6, I don't get 18. So what would I have to do? Maybe multiply by 3. I get 6. 6 times 3 is 18. 18 times 3 is 54. When I multiply 3 times 54, 162. Okay? A trick when we see some fractions. Maybe it's harder to tell that pattern with fractions, but how do I get from 2 to 6? Well, I do multiply by 3. Does it work back here? If I multiply 2/9 times 3, I get 6 over 9, which is 2/3. When I multiply 2/3 times 3, I get 6 over 3, which is 2. You can do that on your calculator. So I would multiply this times 3, and I would get 18. Okay? So why do I have all these jelly beans lined up? This is an exponential function. Remember, an exponential function is in this form right here. Y equals a times b to the x. So if I had this table here, 2 jelly beans, 4 jelly beans, 8 jelly beans, 16 jelly beans, didn't have enough to make 32, but you get the point. We'll get rid of those. Maybe I'll eat some. We want to write a function rule, which a rule just means an equation. I want to write an equation. All right? First steps, we're going to find the pattern in the y value. So I'm going to look to this y values, just like we did up here. What are some patterns? How do I get from 2 to 4? I multiply by 2. Multiply by 2 to get to 8. It's got to work throughout the whole thing. 8 times 2 is 16. 16 times 2 is 32. So 2 is my pattern. Okay? So here the y values are multiplied by 2 for each increase of 1 in x. When I go from -2 to -1 to 0, 1, 2, x's go up by 1. So if the x's go up by 1, in this pattern, the y's go up by 2. So the table represents an exponential function in the form of y equals a times b to the x, where b is the 2. This is the 2, the b value. Okay, it's that increase, or it's that what we have to multiply by when we find the pattern. So we have to find the b. That's what we have to multiply to get the next number. Step 2, we have to find the value of a to write our exponential function. We have b now. I need to find a. So find the value of a by finding the value of y when x is 0. Okay? So I'm going to look at my table all the time. Whenever I see an x value of 0 for x value of 0, I'm going to circle that, and my y value of 8 right here, that's going to be my a. Okay? So a is going to be 8. And that just works out. Wherever the x is 0, my a value is going to be that value, the y value. So when x is 0, y equals ax. A times b to the 0. I can plug 0 in. This is why it works. So anything to the 0 power is 1. So this is a times 1, which is just a. So when x is 0, y is 8, which is the a value. Okay? So what does this mean? Well, this b value, this is going to go right here. So that b value of 2, I'm always going to have an exponent of x in there. The a value is going to go right in the front, and that's 8. So the value of y when x is 0, that's my a value. I circled it up here. Okay, the value you found in the pattern, the number that each y is multiplied to get the next value in the table. That's the b value. So this is the function rule. Y equals 8 times 2 to the x. I cannot multiply the 8 and the 2. They're not the same base. So this is the rule. It's an equation. That's it. Okay, so let's do another one where we don't have all these steps. We're going to do the steps, but they're not written out. So state the exponential function for the table. Write the rule. That's what it means. Okay? So I have to find the pattern, the b. Well, how do I get from 3 to 9? I multiply by 3. From 9 to 27, multiply by 3. 27 times 3 is 81. 81 times 3 is 2. So 3 is my b. Find my a. How do I find the a? Well, I look where the x is 0. I circle this. My a is going to be 27. I have my b and my a and my b. So I'm going to write the rule. So the rule is y equals a, my a is 27, times b, which is 3 to the x. And that's it. That's the rule. We could also check this, make sure. Let's check. So if I checked, I could say y equals 27 times 3. I'm going to put 2 in for x. Okay? If I put 2 in for x, I should get 243. Okay? So that equals 27 times, that's 9. 9 times 27 is 243. So that's good. Because 243 equals 243. So it checks. But it's that easy to write the rule. We got to find the b, which is that pattern. And then we find the a by looking for when x is 0. Wherever the x is 0, the y value is the a. We plug it into that exponential function. Okay? So the next part. It says state the exponential function represented by the table below. So I'm given a table. I got to find this pattern. How do I get from here to here? How do I get from here to here, here to here, here to here? Well, once again, fractions might be a little bit harder, but how do I get from 1 to 2? I add 1 or I multiply by 2. Exponential functions, if we're looking for them, it's always going to be multiplication. So let's see if multiplication works. Whoops, that's 2. Would it work over here? What's 1/2 times 2? You can put it in your calculator. 1/2 times 2 is 2 over 2, which is 1. That works. 1/4 times 2. 1/4 times 2 is 2 over 4, which is 1/2. 1/8 times 2 is 1/4. So multiplying by 2, that's my b. Okay, my a. I'm going to circle this every time. Get in the habit of doing that. When x is 0, circle it. My a value is 1/2. So my rule is y equals a, which is 1/2, times 2 to the x. Okay, we do not multiply these together. Okay? So now let's do a word problem. A population of 15 mice doubles every 6 months. Okay? So state the exponential function that represents the information. We're going to create a table that represents the population for the next 2 years. Okay? So this is the number of 6-month periods. Number of 6-month periods. That's the x. Y is going to be the number of mice. So when I'm at 0, where does it start with? It starts with 15. I have to start with 15 mice, right? And it doubles every 6 months. So this is the number of 6-month periods. So after 6 months, how many do I have? 15 double is going to be 30. After 1 year, I'm going to double this. So another 6-month period is going to be 60. I'm going to double this, 120. And I'm going to double this to 240. Okay? So I got to find my b. How do I get from 15 to 30? 30 to 60, 60 to 120, 120 to 240. Hopefully we see these patterns start to repeat. I'm going to multiply by 2. So my b is 2. My a, right there, x is 0, my a is 15. So my rule, y equals a which is 15 times 2 to the x. Okay? I'm going to keep this part up here for a little bit. We got the next part of the question over here. So based on the information, what is the population in 6.5 years? So we have to find x. Here's where it gets a little tricky. How many 6-month periods are there in 6.5 years? Well, in every year there's how many periods? 6-month periods. There's 2 6-month periods in every year. Right? So I'm going to multiply 2 times 6.5 and I get 13. Okay, if you don't see that, we can multiply, so you have 6 months, 12 months, 18 months, 24 months would be 2 years. There'd be 13 of those periods, okay? You'd have 6, 12, 24, 18, or 18's in there, 24, 30, 36, 42, 48, that's 4 years, and you can keep going, okay, and count them up. So my x is going to be 13. It's key. It says every 6 months, and we got to go into years here. So substitute your x into the rule from, whoops, this should be 3a, okay, and evaluate. So my rule is y equals 15 times 2 to the x. Well, I'm going to evaluate. I'm going to say y equals 15 times 2 to the 13th. I'm going to substitute this in. So when I do that on my calculator, on the calculator, we're going to say 15 times 2 to the 13th power, 122,880 mice. 122,880 mice. That's a lot of mice. Exponential. They grow. That population starts to explode. So what does the b value represent in this problem? This b value right here. That's the b value. What does that represent in this problem? How much the mice population increases by every 6 months. The word in the word problem is doubles, right? It says that this mice doubles right here, okay? And doubles means it multiplies by 2, it increases. So we want to underline the word in the original problem that tells you this information. We want to get in the habit of doing this. We want to underline this word. That's going to be our b value, okay? What does the a value represent? What does this 15 represent? Where did this 15 come from? It said 15 mice. Well, the 15 is, so it represents the starting population, or the initial population, okay? And we want to get in the habit of circling that. So every time we get this 15, I'm going to circle that in the problem. That's my a value. What I underline is going to be my b value. Okay, and that's how I'm going to get to my rule. Oops. So it represents the starting population, or the initial population. We're going to circle that value. So every time we have a word problem, we're going to circle that initial, wherever it starts at, and we're going to underline what happens to it. Does it double? Does it triple? Does it quadruple? Those are the words we're going to be looking for. Okay? So let's try one more problem here. And we want to circle and underline. It's not going to walk us through like it did up here, but this is the type of problem we're going to get. A certain bacteria, given favorable growth medium, triples. Well, I know I'm going to underline that word. Triples in population every 6 hours. That's going to be important too. Given that the there were approximately 100 bacteria to start with. That's my starting population. I'm going to circle that. How many bacteria will there be in a day and a half? Okay, so my B value, that's my underline. I don't write the word triples, but I know it's going to be by 3. That's what triple means. The A value, well, that's the starting point. That's 100. So my exponential function is y equals 100 times 3 to the x. Okay? Now, we have to find x. How many 6-hour periods, because it says the population triples every 6 hours. And they're asking how many bacteria in a day and a half. So we got to get those units right. So how many 6-hour periods are there in a day and a half? Well, you'd have 6, 12, 18, 24. That's one day, right? Then you got 30, 36. So that would be a day and a half, right? Here's one day right here. And then a half a day would be 12 hours. How many periods? 1, 2, 3, 4, 5, 6. So there's 6-hour periods. 6-hour periods. We're not going to multiply with it. It's just 6-hour periods. So x is going to be 6. Okay? I could figure out how many hours are in a day and a half. How many hours are in a day and a half? Well, 24 hours are in one day. So 36 hours, right? How many 6-hour periods in 36? 36 divided by 6 is 6. Another way I can get my 6 over here. Just like that. We're not going to write it out every time. You guys are going to figure it out like this. So we're going to substitute the value into the rule. So y equals 100 times 3 to the 6th. Because I'm going to put that 6-hour periods. I'm going to put that in my calculator. And when we do that, we are going to get 100 times 3 to the 6th, 72,900. So that's going to equal 72,900 bacteria in 1.5 days. I'm going to eat another jelly bean there. So after watching this video, fill out what you can do and what you can't do, what you need help with. On the front page, I want you to write a square on the front page. Write a square on the front page, on the top right of the front page, and do those U-tries for homework. And if you notice, there's something that says you should really try those ones, okay? So we'll talk to you tomorrow. Bye.